Chapter 2, Operating System Early Memory Management. Single User Contiguous Scheme. The entire program or job is first loaded into memory contiguously as much as possible before the execution. To execute the program, either the size of the memory available needs to be increased or the size of the program needs to be decreased to fit in the available memory. Single contiguous memory allocation is a simple memory allocation scheme which requires no special hardware features. Entire available memory is allocated to a single job. In this scheme of allocation, the main memory is divided into three contiguous regions. One portion is permanently allocated to the operating system. Second, what is memory allocation and its type? Memory allocation is the process of setting aside sections of memory in a program to be used to store variables and instances of structures and classes. There are two types of memory allocations possible in C: compile time or static allocation, runtime or dynamic allocation. Fixed partition. The earliest and one of the simplest technique which can be used to load more than one process into the main memory is fixed partitioning or contiguous memory allocation. In this technique, the main memory is divided into partitions of equal or different sizes. The operating system always resides in the first partition, while the other partition can be used to store user processes. The memory is assigned to the process in contiguous way. In fixed partitioning, the partitions cannot overlap. A process must be contiguously present in a partition for the execution. There are various cons of using this technique. 1. Internal fragmentation. 2. Internal fragmentation. 3. Limitations on the size of the process. 4. Degree of multiprogramming is less. Next, dynamic partition. Dynamic partitioning tries to overcome the problems caused by fixed partitioning. In this technique, the partition size is not declared initially. It is declared at the time of process loading. The first partition is reserved for the operating system. The remaining space is divided into parts. The size of each partition will be equal to the size of the process. The partition size varies according to the need of the process so that the internal fragmentation can be avoided. Examples of dynamic partitioning. Here, process 1, process 2, process 3, and process 4. Advantages of dynamic partitioning over fixed partitioning. First, no internal fragmentation. Second, no limitations on the size of the process. Third, degree of multiprogramming is dynamic. Advantages of dynamic partitioning. First, external fragmentation. Second, complex memory allocation. Deallocation. Deallocation of memory by the operating system is a way to free the random access memory of finished process and allocate new ones. We all know that the computer memory comes with a specific size. Have you ever wondered how it manages to do everything it does? It does so with the help of a robust memory management technique that handles all the allocations and deallocations of processes. A process has to be loaded into the RAM for its execution and remains in the RAM until its completion. Finished processes are deallocated or removed from the memory and new processes are allocated again. In relocatable dynamic partition, memory manager and operating system relocates the program. That is, all empty blocks are gathered to form one single block of large memory enough to accommodate some or all of the jobs waiting in the key. that is relocatable dynamic partition.